Hi friends, my topic is industrial chemical production. Here we are going to discuss about the production of alcohols and acids. First of all, in this video we are going to see an introduction and a history about the chemical production and industries, and then about the production of alcohols. So let's begin. What are chemical industries? These are companies which produce industrial chemicals, and the raw materials like oil, natural gas, air, water, metals, and minerals are converted into many different products. Plastic industry are also there, but the same chemical companies which produce chemicals also produce plastics. History. The Industrial Revolution. Sulfuric acid was the first chemical to be produced in a large scale, and Joshua Ward, who was a pharmacist, in 1736 developed a process in which saltpeter was heated, allowing the sulfur to oxidize and to combine with water. And then John Roebuck and Samuel Garbett established a large scale factory in Prestonpans, Scotland in 1749, where they used condensing chambers for the manufacture of sulfuric acid. In early 18th century, bleaching of clothes were done by clothes treating with stale urine or sour milk and exposing it to sunlight for long periods of time, and this was a very time consuming process. And in the middle of the century, sulfuric acid and the lime was used. Then Charles Tennant discovered the bleaching powder, and the powder was made by reacting the chlorine with dry slaked lime. This was a very successful product and also very cheap. Soda ash was used since the ancient times in the production of glass, textile, soap, and paper, and the potash source had been traditionally the wooden ashes in Western Europe. William Loesch built the first soda works in Britain, and Ernest Solvay patented for an improved industrial method for the manufacture of soda ash. In late 19th century, there was an increase in both quantity of production and also the variety of chemicals which were manufactured. Large chemical industries also took shape in Germany and then later in United States. Production of artificial manufactured fertilizers for agriculture was developed by Sir John Slavish. At present, the chemical production is a very high-tech industry where the competitiveness is based on the capacity in investment on R&D than the labor cost. Products mainly include polymers, bulk petrochemicals, intermediates and other derivatives, and basic industrials, inorganic chemicals and fertilizers. Industrial production of alcohol. We mainly focus on the production of ethanol. Introduction. Ethanol is used as a solvent and as a chemical intermediate and also as a fuel. Solvents are resins, pharmaceuticals, cosmetics, householding, cleaning products, industrial solvents, etc. Fuels like biofuel and internal combustion engines. Chemical intermediates are petroleum derived chemicals and butadiene production. Organisms used are in bacteria. Many bacteria can produce ethanol, and also many produce as end products other alcohols, organic acids, polyols, ketones, gases, and many bacteria metabolize glucose by EMP pathway, such as Clostridium species, Spirochaeta species, Sarcina species, Streptococcus species, etc. In yeast, the primary are Saccharomyces species, and organisms are selected by high growth and fermentation rate, ethanol yield, osmotolerance, low pH, high temperature, hardiness under physical and chemical stress, ethanol and glucose tolerance which allows the conversion of concentration feeds to concentration of products. Raw materials needed are saccharin, starch, and cellulose materials. Saccharin are simple, directly fermentable 6 to 12 carbon molecules, and glucose, fructose, maltose can be used. Fruits are grapes, which contain 50%, banana 13.18%, apples 12.2%, pineapples 11.7%, pears 10%, peaches 7.6%, oranges 5.4%, and watermelon 2.5%. Then molasses, beet or cane molasses, and they contain 52 to 55% fermentable sugars, and molasses with above 15 to 12% sugar content will need to be diluted. A ton can yield 70 to 80 gallons. And cane sorghum, 14% fermentable sugar content is there, and extraction requires a very heavy process or duty. 13 to 14 gallons of alcohol or can be obtained. Acidification is necessary. In sugar beet, this is the mostly preferred one. 15% sugar, 82% water, and small amount of starch are present. Juice is extracted by crushing. A ton yield 20 to 25 gallons of alcohol is obtained. Use of enzymes can improve the yield. Sugar corn waste, 7 to 15% sugar. Sugar is extracted as same as sorghum. 8 to 18% gallons of alcohol per ton, and backsloping in the range of 20 to 25%. Acidification is also necessary. Starchy materials which contain complex carbohydrates are known as starchy materials. Grains, it must be milled, diluted, and cooked and fermented. These processes should be done if we are using grains, and they contain large amounts of fermentable materials, and alcohol yield is dependent on the converted starch. Jerusalem artichokes, it contains abundant source of abundant alcohol. It contains 60 to 80% and is a fermentable material, and 25 gallons per ton of alcohol is obtained, and materials should be crushed to pulp and cooked to 2 to 3 hours, and dilution is not necessary as it contains 79 to 80% water. So this is a diagrammatic representation of how we use it as a biofuel, how we use ethanol as a biofuel. So here we can see harvesting, then milling, the process of milling, and then filtration and fermentation. By fermentation we can get approximate to 10%, and then in distillation we can get 10 to 90%, and the test or dehydration we will get 99.6%, and this is mixed with the gas. 3% is mixed with the gas and then used as biogas. The pH is adjusted and fermentation is carried out. And potato, 15 to 18% fermentable sugar is there, and 20 to 25% yield of alcohol can be obtained. This is cooked with steam under pressure. After cooking, mash is cooled. The mashed one, after cooking, it is cooled to conversion for 15 to 20 minutes. And once converted, pH is adjusted and mash is fermented. Sweet potato, it contains 27 to 28 fermentable sugar. We can get a yield of 40 gallons per ton of alcohol, and the process is similar to potatoes and dilution is required. The processing steps. The starchy materials are of two categories: encased by grain hulls and a starch which is readily available. Malting, the seeds are moistened and allowed to sprout, and these seeds are powdered, and the powder is called malt. Milling, grains are milled to expose the starch. The material is grounded as fine as possible. The fine flour which is obtained by milling is difficult to remove in distillation process. Pot stills may reduce the problem. Cooking, or how to prepare the mash. Starch is liquefied by boiling under pressure, and to dissolve the water soluble starches, always done with steam under pressure at 100 degrees Celsius. Water is used less during cooking, and water is added to dilute the mash. So cooling time may be saved. New method is there, and which is milling and cooking in one operation without the use of water. The cooked malt is called mash. Then comes conversion. The starch is converted to fermentable sugar like maltose by certain enzymes in the malt or by acid hydrolysis. Enzyme extracts, commercially available, three basic types, which are alpha amylase, beta amylase, and glucoamylase. Alpha amylase produce dextrose, and the other one produce maltose, and the last one reduce the remaining starch. Acid hydrolysis, uh, it, it is the conversion by the action of acid. It requires acid proof equipment and very high temperature. Dilute the mineral acid like H2SO4 and is added to grain slurry. Then immediately neutralized with a calcium hydroxide. Mash cooling. Mash is cooled after conversion and the pH is checked. Cooling coils are used for cooling. Cooling time is reduced as much as possible. Fermentation. Batch fermentation is the most commonly employed method, and fermenter volume is 600 meter cube and 3% inoculum is used. Within 12 days, yeast produce 10% ethanol. When the process is carried out at 35 to 38 degrees Celsius and pH at 4 to 4.5, the productivity was 1.9 per hour. 80% cells were removed in separator and brought back again into the fermenter. When the high quality molasses is used, the maximum yield obtained is 95%. So this is a diagrammatic representation of what we told here, and we can see the corn which is grinded and then cooked and then liquefied, and here we can see the enzymes or yeast is added into it, and then this is saccharified and then fermentation. From fermentation we can see it is gone to distillation, centrifugation, then distillers grains, and centrifugation to evaporator and to distillers solubles. So from distillation we can obtain the ethanol, and in between in fermentation we can also obtain carbon dioxide. How we recover the product. The cell biomass is separated by centrifugation or sedimentation. The desired end product is heated, readily separated from the broth by sedimentation. We get the desired end product metabolite, and intracellular products are nucleic acids, vitamins, enzymes, and extracellular are amino acids, acetic acid, citric acid, alcohol. and then penicillin, streptomycin, etc. Separation of cell biomass is done by four, such as flocculation, filtration, flotation, and centrifugation. In flocculation, flocculating agent is added, hydrocolloids, inorganic salts, organic polyelectrolyte, etc. Produce large aggregate which still settle more readily. Flotation, which is by introducing gas into the liquid. Cells gets adsorbed to the gas bubbles and rise to the foam layer at the top of the vessel. This is then collected and removed from the bioreactor. Filtration, bacterial cultures can be used, which requires bacterial cultures are filtered using absolute filters or filamenters, and for fungi, depth filters or static and cross flow filtration are used. Distillation, this is the separation for a mixture of liquids, relies on differences in boiling points of component liquids to be separated. The mixture to be separated is added to the distilled pot and heated. The low boiling point will vaporize first, and this passes into the distilling head and then into the condenser. Within the condenser, the vapor is cooled and liquefies. The resulting liquid is then collected in a receiving flask. So this is the distillation. This one we have seen in the laboratory, and we have done, and this is used in the large scale. And we can see the distilling pot from which by evaporation it goes up, and here condensation occurs, and this is the collecting or receiving flask. And in the large scale section we can see the heating element and the mash, from which the vapor goes, and this is the condenser here, and this is surrounded by cold water and water jacket. And when it goes through the condenser, vapor passes through the condenser, we can it liquefies, and there is a collector here. The cold water used can be drained through drainage. Ethanol boiling point is 78.5%, 5 degrees Celsius. Water boiling point is, as we know, 100 degrees Celsius. The purification is by chromatography, like HPLC, GLC, etc. Applications: solvent in the manufacture of varnishes and perfumes, preservative for biological specimens, and in the preparation of essence and flavorings. In many medicines and drugs, as a disinfectant, and in tinctures used as a biofuel. Medically, ethanol is soporific, uh, used as an antiseptic. Fluid in many alcohol thermometer. 92.4% ethanol used as solvent in cosmetics, pharmaceuticals, and chemical industry. The byproducts are DDGS, which is distillers dried grain with solubles, carbon dioxide, which is used for production of dry ice and preparation of soft drinks, yeast biomass, animal fodder, which contains both proteins and vitamins. So this is about the production of ethanol. Thank you.